welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. All right, hi everyone. Welcome to the House of ZK Radio podcast. My name is Alice. I'm the host of House of ZK Radio, and I'm joined here today with Michael, who is co-founder of Brevis. Super excited to have you here today, Michael.
Thank you, Alice.
Yeah, of course. I'm wondering if we can first start off with an introduction of yourself, maybe how you got involved in both the Web3 and ZK spaces.
Yeah, sure. Hi everyone. This is Michael. I'm co-founder of Brevis. So I got involved in blockchain pretty early on when I was doing my PhD in computer science in UC. I did a bunch of research on layer 2 scaling, and then later founded a project called Stellar, which is one of the biggest cross-blockchain interoperability platform, or cross-chain bridges, basically. And we got involved in ZK more recently, since last year, because we saw there's a very strong need to actually amplify the kind of capacity and the computation you can do on blockchain further to allow blockchain and smart contract application to be more intelligent.
Yeah, definitely. And it's just speaking about that idea of allowing for blockchain and smart contracts to be more intelligent. I'm wondering if you can talk a little bit about the smart contract capabilities today and their limitations, like not being able to, for example, access that on-chain historical data and some other challenges relating there.
Yeah, sure. So, definitely from kind of a scalability point of view, we have come a long way in terms of on-chain scaling and, with rollups and, everything. But if you look at the entire architecture of blockchain today, it is still very much a monolithic architecture where you have just one, single blockchain, be that layer 1 or layer 2, running the different type of application all in one machine. So what that means is that the highest level of scalability you can get from that is no more than just a single server. It is replicated computing, it's replicated storage, a lot of communication overhead, and you cannot get anything bigger or more powerful than a single machine. So how can we break that, right? So that's the question we want to answer. Now, why we need to kind of do that is because, for example, if you want to build some very, very simple features like VIP trading programs, let's say you traded a lot on a DEX, you traded like $10 million volume in the next month, you want to get a fee discount, right? So differentiated fee between different users. If you look at all these centralized exchanges, every single one of these centralized exchanges have them, right? But if you look at all the DEXs, none of the DEXs has this type of feature because it is very, very hard for a smart contract to actually access and compute on historical data. So the reason it is very hard is because accessing and compute on these data involves a type of computation that is simply too heavy for the blockchain to handle, even for layer 2s. So this is where we realize that even for building features that improve user experience just by this little, you actually break the entire assumption of the monolithic blockchain architecture. And this is where we think that some new technology and new architecture should be built, and this is why we introduced Brevis.
Definitely moving from that monolithic stage to a more kind of modular component. Yeah, I see. And I'm wondering if we can also talk a little bit about how the developer experience is addressed as well, because like right now, even for ZK adoption, we see, even though we have seen things like improvements in proof generation costs, ZK is becoming a bit more accessible, but there's still a lot of barriers when it comes to adoption. I'm just wondering your thoughts on why we haven't reached that mainstream level of ZK as of today.
Yeah, of course. So, I think there are two aspects to this. One is on the developer friendliness side. So ZK, in the beginning is very, very hard to use technology. You need to understand a lot of mathematical concept. You need to understand a lot of constraints when programming ZK. It's very, very different mindset when you're building a ZK-based functionality and programs. So this is why it is very important to have a way to have this kind of a programmable SDK present to the developer. So developer, when they're trying to leverage the power to offload certain kind of a complex computation to a ZK environment and bring it back to the blockchain, they don't need to understand what is the underlying mathematical complexity there. So they just need to understand, okay, I want to compute what is the user trading volume. I want to compute what is the user's behavior. I want to offload that computation to an off-chain environment, which is cheap and fast, and then bring that result back to the blockchain directly. So they don't need to understand anything about the underlying ZK. So that's the first point we strive to achieve at Brevis. Now, the second part is that, developer friendliness is not enough, right? Because, you still have to be able to undertake the workload of, production use cases. Let's say, for Uniswap or for PancakeSwap, there are hundreds of thousands of daily active users on a daily basis. If you want to do any computation on those historical data, it is actually pretty high load for ZK to kind of do that computation as well. Because for ZK, you're not only just doing the computation of the result, but also generating a ZK proof to make the entire process end-to-end trust-free, right? So, for that, you really need to have the capability to have a very, very nice trade-off point in the scalability and developer-friendly space. And we believe what we're trying to do here is that we find that very sweet spot of the trade-off space, in the trade-off space, and allow developers to build very production-ready, ZK-powered features. At the same time, don't need to worry about any of the details.
Got it. So both focus on the front-end experience, but then also that scalability part with the workloads. Got it. Nice. And also wondering if you could talk a little bit about, for anyone who in our audience who's not too familiar, you guys are working on building a ZK coprocessor. I'm wondering if you can talk a bit about the difference between the capabilities, limitations, and also opportunities between coprocessors and also rollups.
Oh yeah, sure. This is actually a very great question. So what ZK coprocessor is fundamentally is a scaling solution, right? So what it does is that it allows a developer to move some of the computation that is very hard to do on chain to an off-chain environment. And when you're moving things off-chain, the immediate question is like, how can we ensure the entire computation process is still trust-free, right? How can we ensure security, decentralization of the computation? Well, that's where the ZK of the ZK coprocessor comes in play, where you're not just computing the result, but also generating a zero-knowledge proof of the computation process. So this zero-knowledge proof is very succinct and very easy to verify proof that can be brought back to the blockchain along with the computation result. The blockchain smart contract can then verify the ZK proof with extremely low cost and then use the computation directly, right? So this is the pattern of a ZK coprocessor as a scaling solution. Now, how does that compare with a ZK rollup? I get this question a lot, right? So, I think one way to look at this is from a trade-off evolution, perspective, right? So in the beginning, if we're looking at layer 1 blockchain, we have a 3-dimensional trade-off space, which is decentralization, security, and scalability. This is a famous, the blockchain trilemma, right? So, obviously, Ethereum chose the direction of high scalability, high security, and the high decentralization at the cost of very relatively low scalability. Now, how do we break that? Well, we break that by introducing a new dimension in the trade-off space, which is unity, like state unification, and the state and user unification. So this is what layer 2 rollup are actually. So it basically trade off the unity and then increase significantly on the scalability front. So what this means is that it's faster, it's more powerful, but we have a lot of rollups, which means that now state and user and liquidity are all fragmented. Right, so that's kind of the trade-off that we made on the layer 2 space. There are a lot of great work. You guys are doing some amazing work on that to kind of try to find the right trade-off curve, the sweet spot for that. But it's the fundamental trade-off that we made. So, can we, what ZK coprocessor is we are yet introducing another, trade-off dimension in the entire trade-off plane, which is, synchrony. So with ZK coprocessor, you're scaling up blockchain to a level that is, that is breaking the limitation of a single server, because you can have parallel ZK coprocessing run by multiple different threads, by multiple different kind of processing approver processes, and therefore scaling the blockchain, capacity to, in theory, infinite amount, right? But the trade-off coprocessor is making, and also at the same time, everything is concentrated on a single chain. There's no liquidity fragmentation, user fragmentation, or state fragmentation. But the challenge and the trade-off here we're making is synchrony. So instead of getting feedback or getting the result of every single smart contract call at the same time, whenever you call it, you get a result directly from the smart contract. Now we're introducing a asynchronous design pattern to blockchain. So that is like okay, the smart contract need to compute something, and then it send out a request. And this request get offloaded to an off-chain environment, and it's done. You don't get the result at this exact same moment. You wait for a while after the computation is done, and then you get the result via a asynchronous callback, right? So that is the pattern changing that, or a trade-off dimension that is introduced by ZK Coprocessor. And I do feel ZK rollup and ZK Coprocessor fill very different roles. That they will kind of both thrive for a very long term.
Got it. Yeah, so it's not like one is competing against one each other. It's just that they're both used for different applications, and then even the trade-off planes, as you mentioned, are different with unity within rollups, and then also synchrony within coprocessors.
That's right.
So it's really good that you made that differentiation.
Yep.
Also wondering a little bit about the use cases and applications that come with ZK coprocessors and how they differ within rollups, and also very curious to hear about the use cases that are being built on Brevis right now, or maybe ones that you would like to see built in the future.
Yeah, so like broadly speaking, we see right now 3 major categories of use cases. One is what we call intelligent DeFi or intelligent DApps. So what they are is that because like before Brevis, there's no way for a smart contract to access historical states and data and user behavior. Right, so now with Brevis, what developers can do is they can actually leverage these kind of a powerful data insight directly in their applications for things like user loyalty rewards, for things like LVR protection, for things like continuous reward programs and stuff like that. So these are the things that we essentially allow these DeFi protocols and applications to dynamically change their protocol parameters based on the historical behavior of users and also the market, right? So you can have a lot of intelligence in your application to differentiate between user behavior and to dynamically change how you charge user, what is the risk parameter in lending protocols and everything. So, there are a large sum of application partners we build with. For example, some of them are already launched on mainnet. Quanta, which recently is being acquired by Synthetics, is one of the major kind of perpetual swap aggregator. And what they use us for is to build a market maker VIP fee rebate program that allows market maker to prove on-chain directly what is the trading volume that they did in the past months and get a fee rebate. So we actually found out that this solution allows market maker to provide a better market structure so that uninformed order flow can flow into these aggregators more and boost the bottom line and the revenue for the aggregator itself, right? So this is why this kind of a loyalty program market maker rebate works in centralized exchanges, and they are now also working in decentralized exchanges. We're also partnering with PancakeSwap, as we will announce very soon, on similar features and many more. So one other aspect is on the consumer and mass adoption front, right? So one interesting thing that I want to highlight recently is that we are launching very soon with a stable token issuer called Euro. For a continuous protocol incentivization program. So we all know airdrop sucks, right? So like it sucks for both users and protocols. It's a disappointment for users, and it's a huge cost center for protocols because we really need to overcompensate users. And for users, it's really black box. There's no way to know what is the rules. And Euro, oftentimes now we have this kind of a very toxic cycle of essentially farm, claim, sell. Right, so like you farm the airdrop, you claim the airdrop and sell the airdrop and leave the project ecosystem. It becomes very institutionalized. It has deviated from the initial assumption of the airdrop. It's like a nice surprise that no one knew about before, but now everyone knows. So now we are in the era where we know this is a good way to incentivize user, but we need to do it properly. So this is where we partner with like Euro to run this type of a continuous protocol incentivization program that allows user to continuously and in a very decentralized way. There's no one sending out these tokens, but users are just generating proofs of their on-chain behavior of using Euro's stable token ecosystem. And using that, they can essentially claim from the user token repository directly in smart contract without any intermediary. That okay, I actually did this much contribution to the Euro ecosystem. Therefore, I'm claiming this much token in the token emission process and token minting process, right? So that's how we think this coprocessor will actually fundamentally shift the most important, one of the most important things in the crypto space, which is token launch and token distribution. And there are so many more like infrastructure level things. We work with many block space trading, a block space market, solutions to allow trust-free claim and settlement of block space trades like break confirmation and stuff like that, and also data availability solutions like zero gravity and so many others as well.
Oh, nice. Very exciting. And especially with that continuous incentivization, I feel like a lot of protocols can adopt that because everyone has that challenge where they have an airdrop launched, but then people, they come, claim the award, and then leave right after. But then how do we retain that kind of engagement for that project long term? And I think that part when you mentioned about not having that intermediary where users don't really need to prove everything that like they've done to contribute, that part's really powerful. So very exciting time that we're in.
Yeah,
I think, yeah. Also very curious to hear about your thoughts with generalized ZK, because right now we're seeing a trend where we're adding abstraction layers on top of traditionally writing circuits directly or using frameworks like Circon, but now we have ZK VMs, we have coprocessors, and we're really adding onto that abstraction layer stack. I'm wondering about your thoughts in terms of like the differences between our traditional ways of writing the circuits directly, which you mentioned kind of in the beginning of this interview, where like users, they don't need to, right now, they don't need to deal with having to know all the math behind writing ZK, having to know the cryptographic background. But I'm wondering if there's any kinds of trade-offs or significant trade-offs that you see behind writing custom ZK circuits versus using higher level abstractions, maybe like the benefits, but then the costs of each approach.
Yeah, for sure. So like, when we started to build, ZK coprocessor, our goal is to push the ZK coprocessor to market with specific use cases in mind, right? So like intelligent DeFi, like kind of a continuous, protocol reward, automated intention, and everything like this. So, we came from a world where we know like a lot of DeFi protocols in the past, and, we know their need and we know their scale. So when we're talking about trade-off, the most important thing is to understand what is the potential customer and what are potential use cases. Now, for our targeted use case to go to market fast, to get real adoption, we feel it is very important to maintain an extremely high level of high level of efficiency and scalability. At the same time, have sufficient amount of programmability so that the developer can use the framework without actually writing any ZK circuit. So this is where we start, right? So, we think this is a good approach because this is very suitable for the use cases we're building with our partners. Now, there are obviously different starting points. For example, ZK VM, generalized ZK VM as a very good example. Now they start with like very, very generic logic, generalized logic that can handle many different kind of business use cases, but with a significant trade-off at the performance level, especially if you want to kind of do a lot of specialized computing, like access historical data and compute on the historical data. But they also have benefit because their target use case is different. Like like OP stack, proving OP optimistic rollup using ZK, like building aggregation layers like ZK, what ZKM is doing, requires very complex and sophisticated logic that is very hard to express using a very specific framework. Now, I think both of these solutions are picking trade-off point right now on the trade-off plane that has good adoption and traction possibility into the future. Now, however, I do see that these two trends are moving towards each other very quickly because ZK VMs are becoming more and more specialized with precompiles, with recursion frameworks to take in certain kind of a result computed in the ZK coprocessor space, and ZK coprocessors like us are also becoming more and more generalized to allow more complex business logic like not only just data stream API, but the signature verification hash, tree-based computation, everything that is encapsulated in the, kind of a more of a DSL framework, right? So, I think at some point, these two trends might merge. And in the next 2-3 years, we'll start to see a more generalized framework for developers so that they can freely merge different solutions together to build coherent applications whenever they want.
Mm-hmm. Yeah, definitely very excited for that kind of merging together. I think that there's a lot of fragmentation even within the developer tooling space. So having a way where they can choose the different models they want to use, or kind of see what frameworks are available and use all of them would be really great, at least on the developer side.
Yeah.
So very excited for that. Also shifting a bit more into the kind of models that Brevis is focusing on. I know that you guys really emphasize on the differentiation between the pure ZK versus cryptoeconomic plus ZK model. So I'm wondering if you can touch upon that and maybe speak about the differences between the two models, but then also the advantages that one provides over the other.
Yeah, for sure. So in Brevis, we offer two different kind of computing models. One is pure ZK. That is, you offload your computing in the ZK land, and you compute everything and bring it in ZK proof. So everything is in capital ZK, 100% trust-free. Now, as I kind of mentioned many times, I guess I'm a trade-off fan, right? So our goal is to offer developers the largest trade-off plane possible for they to build different kind of use cases they want with different cost and efficiency profiles. So this is why, in addition to the pure ZK model, we also introduced something called a crypto economics plus ZK model. Now, what does that do? Is that that is essentially a way. It's more like an optimistic rollup with ZK fraud proof to make it simple. So what that is that instead of offloading your computing to a ZK coprocessor every time, you can offload your computing to an optimistic proposer, right? So the optimistic proposer, in this case, an eigenlayer AVS, will do the computation first without actually incurring any of the cost to generate a ZK proof. The result will then be posted back to the blockchain. And, but obviously that is not at the same level of security of a pure ZK solution. So, what do we do about that? We open a challenge window, just like optimistic rollup, right? So just like optimistic rollup, you have a challenge window of 7 days. But in our case, the challenge window can be much shorter because we actually, the fraud proof or the challenge process is actually done in ZK. Now, if you want to have let's say if somehow the optimistic proposer proposed the wrong result, then the watchtower can quickly generate a ZK proof to challenge that and slash the the optimistic proposer for their stakes. Now, the reason we chose to build with eigenlayer is because eigenlayer is a very efficient way to acquire staking capital, and allows very efficient operations of this model with default security of a proof of stake security, right? So we could have just used a centralized proposer, but we want to bring some default security level to the table with slashing capability already basically built in, right? So that's the nature of the CE plus ZK model. This offers developer a significantly reduced cost to the level similar to a centralized solution. But at the same time, it offers the cost level to the significantly reduce the cost level, but the security level is still at the same level of ZK because in the end, we have the ZK fraud proof as a last line of defense, right? So this allows developers who wants to build application use cases that is not so latency sensitive, but very cost sensitive, can choose to use this model to reduce the cost, but at the same time with a little bit of cost of latency.
Oh, got it. Yeah, so it's very interesting to see kind of the merging of both the optimistic and ZK side to have that challenge window where it's not just 7 days anymore, but a bit shorter because there's some assistance on the ZK side. So very good to see the merging of both worlds coming from both solutions. Also wondering, so you guys also worked on a Pantheon of ZK frameworks project, maybe around a year ago, if I remember correctly. But just wondering, relating to that, if kind of the results that you found in terms of creating or organizing frameworks that are focused on the developer side, if that could be applied to how we can see benchmarking standards today, stay with ZK VMs or any other kind of ZK projects, can those learnings from that framework project also apply to what we see today with benchmarking?
Yeah, we're definitely attempting to do that. But benchmarking is very useful. Like I think we should really build the ImageNet for ZK, right? So like in the machine learning space, they have ImageNet, which is standard benchmarking process. It's not just like a kind of a bunch of images that you train on, but it's a very, very standard process to understand and evaluate how is like a different workload handled in different machine learning models, especially for the visual ones. And I do think there's a chance to actually build a standard benchmark set for ZK VMs as well, not only on the frameworks level, but also on the ZK VM level. The reason right now it's very easy to build it in the framework level is because the workload is very well defined. But on the VM level, the workload cannot be like just computing Fibonacci, computing some hashes. It should not be the low-level workload. It should be at the same level of the business logic that is going to be run on these ZK VMs and ZK coprocessors, right? So things like historical data access and computation is a good candidate. Things like generating proofs of a ZK VM trace, a EVM trace is a great example. Things like generating light client proof for the Ethereum consensus is also another great example, right? So now these things, I think like over time, will allow us to get a better understanding on a holistic level how different high-level ZK framework perform on the application level where like application developers really care about.
Yeah, I see. So we should focus more on kind of the real use cases that devs are focusing on or building, not just say like proving Fibonacci, for example, those kinds of toy examples.
Yeah.
I see. Okay.
Precisely.
Yeah, I see. And also wondering if you wanted to speak a bit about what Brevis is focusing on. I know that you guys are now looking into ZKML, and then you have a SPA-ZK project coming up, or kind of component coming up. So what opportunities will that lead for developers, if you want to speak more about what people in our audience can look most forward to?
Yeah, so for sure. So, recently we launched the SPA-ZK, right? So like, our vision in general here is that we believe, we treat ZK Coprocessor as the first product, really. So what we're building here is a new architecture to allow blockchain to act essentially as a glue point of very, very difficult and complex computation. And our vision is that in maybe next 10 years, most of the computation is actually not going to happen on chain, but it's going to happen in an off-chain environment. And this is the future we're building towards too. Now, how can we migrate that many different kinds of computation to the off-chain environment? Well, ZK Coprocessor is the first step. But we're also moving towards many different kind of directions to offload other type of complex computation, and machine learning is definitely one, right? So what we did in SPA-ZK, the key intuition behind that is that when we're talking about verifiable AI, that is, we can verify whether a output of the AI model is actually from a committed or authorized or pre-confirmed or pre-agreed on model. Right, so like if you ask like what is the diagnosis of a certain symptom, and the AI model get you an output, do you know how do you know whether this output is generated from really a powerful AI model instead of just something that is kind of put together in the last minute, right? So this is a kind of what verifiable AI is about. Now in verifiable AI, a common technique that is used is ZKML to essentially use ZK to prove the entire inference process. But the challenge here is that we have been treating ZKML problem as only a ZK problem. So we take the ML model and we apply ZK on it, which is very difficult, as you can imagine, because ML model is inherently not ZK friendly with a lot of flow points and numbers and everything. So now what SPA-ZK did is to treat ZK and ML as a holistic problem, to do cross-stack optimization of both, to understand, there is actually ways to simplify very large, machine learning models to an extreme level of ternary network where like the weights are just 0, 1, 0, 1, 0, 1, and then use these kind of a simplified model with extremely high level of accuracy comparing to the original model, and propose a very, very unique ZK framework based on GKR subtrack to fit into that model, so that we can achieve close to 100 times improvement on the ZK on the verifiable AI inference performance. So that's like the key insight we try to bring to the table, right? So like again, like trying to kind of introducing a new dimension in the trade-off space, right? So yeah.
Yeah, introducing more dimensions to that trade-off plane. Got it. And yeah, very much like how you mentioned, you're trying to become that kind of glue point and optimizing for that future where most of our off-chain computation or like computation is done off-chain. And very excited to also see new capabilities happening within ZKML, and especially like with how much like data-intensive activity is happening within the ML space. Incorporating ZK, as you said, is a challenge, but we're working towards it. So very excited to see that work being done. And just as a last question before we close off today's episode, if you want to give any sort of announcements to the audience, or if you have any specific advice that you would like to give to the audience as well, feel free. But yeah, just any announcements or any sort of advice before we close off for today.
Yeah, sure. So I think the biggest takeaway that I want to kind of deliver to the audience is that ZK technology today is ready. It is ready for mass adoption. It is ready to production use cases. There are many different partners building on Brevis today, and we have a production-ready SDK that is very easy to build. Whatever feature you want to build, data power feature, to build complex intelligent features in your application depth. And if you're interested in working with us, just let us know. Our Telegram is very open, and our DM is also open on Twitter. So just reach out. I would love to kind of join effort and build it with you guys.
Yeah, thanks so much, Michael, and really appreciate all the insights again today for kind of navigating through those trade-off planes and then opportunities for ZK coprocessors, as well as how you guys are really focusing on that developer experience. So really enjoyed our conversation today, and thank you so much for joining HowZK Radio.
Same here. Really enjoyed the questions. Thank you, Alice.
Yeah, thank you so much.